Hi, I'm Captain White of 741 Elgin Air Cadet Squadron, where I'm the training officer and the ground school instructor. Today we're going to talk about a few of the subjects that Level 2 cadets are introduced to during their training year about aviation and theory of flight. Now that question, what is it that allows a bird to fly? How does that happen? Well, the answer is lift. To describe what lift is, we're going to look at one of the theories that has been studied in the past by a fellow named Daniel Bernoulli. Now, Daniel Bernoulli is a Swiss mathematician from the 1700s that studied fluid dynamics. And what he discovered was that a fluid has a relationship between its speed and its pressure. So we call it Bernoulli's theory when we talk about the production of lift. So a fluid system has energy in the form of speed and pressure. And what he found was if the speed of the fluid increases, the pressure decreases. And inversely, if the speed of the fluid decreases, the pressure increases. Well, what does that mean for flight? Well, if I were to take this piece of paper here and I were to blow over the top of it, I'm going to put air over the top of this piece of paper. Now, he studied fluid dynamics, but don't forget, air is also a fluid. We just can't see it. So when I blow across this paper, something peculiar happens. Notice the paper rises. What you're seeing there is the production of lift. What that's happening is the air is going over the top of the surface and it's increasing in speed relative to the air velocity underneath, producing a lower pressure on top. Well, looking at it perhaps in a way you might recognize is an aircraft's wing. An aircraft's wing is called an airfoil. So if air passes over the top of the curvature or camber of that airfoil faster than it does on the underside, Bernoulli's theorem states that the velocity increases, that produces a lower pressure on the top and a relative higher pressure on the bottom. That is the production of lift, basically, from Bernoulli's theorem. Now you might say, the shape of the object matters. So airflow across an object will behave differently depending on the shape of that object. You can see here that air striking that shape would behave differently than air striking that shape than it would on that shape. The shape of the object is very important. Streamlined like a fish is the way you want to be. Remember fluid dynamics, air is a fluid. Too bad we can't see it, but I know you felt it before. Imagine you're driving in your car, you stick your hand out the window, you go like this, you feel a resistance. You go like this, you don't. You can play and feel the resistance of that invisible fluid, but wouldn't that be cool if you could see it? Well, here at 741 Aviation Laboratories, we have done just that. What we have done, there's an instructional guide, EO, that is the building of a wind tunnel. Now, we're going to talk about what a wind tunnel is. A wind tunnel is a system that allows air to flow through and be very concentrated in one area so that you can see its behavior of an object. So what you have is an intake portion of the wind tunnel. Then you have the test portion of the wind tunnel where you're studying your object and see how the fluid interacts with it. And then you have the exhaust or the output area of that wind tunnel. Well, that's a little bit more technical here. At the beginning of the wind tunnel, you have a settling chamber, which allows the airflow to straighten. Then you have the contraction cone of the wind tunnel intake, where it takes a large volume of air and contracts it down to a small, faster stream of air. Then you have the test section there where you can put your object. And then after it is viewed, the air is diffused, slowed down out the diffuser, and it is exhausted out. But something has to move the air through that way. And what we have is the drive section here. And usually that's a fan that blows that way, sucking the air through the wind tunnel. So this is what it looks like. Air is taken in at the settling chamber, contracted and speeded up in velocity. The test section is very fast, smooth stream of air, and then it is diffused out the other side. Well, here at 741 Air Cadet Test Facilities, we have done just that. We've made a wind tunnel. Come and see. Now this is 741 Squadron's wind tunnel for testing aerodynamics. This is the intake section, which includes the settling chamber and the contraction cone. As the air passes towards the test section, you'll see that there's a mechanism to put the airfoil shape in there to test its aerodynamics. We can adjust the angle of attack of the airfoil with a lever. And this is the exhaust section of the wind tunnel that includes the diffuser and the drive section. We're going to tuck around the corner here and take a look at the fan powering this system. It is a Honeywell turbo fan. Now we've started our Honeywell turbo fan to get the air flowing through the wind tunnel so that it comes through the intake, passes through the test bed and out the exhaust. Then we'll place the object inside the test bed there, but in order for us to see how the air behaves over the airfoil, what we've done is we have purchased and fitted the wind tunnel with a smoke machine, one that you would find at a dance hall, producing smoke, ejecting the smoke into some manifold nozzles, and it will pass through the test bed through these tubes over the object. Now to make sure it seals well and the air flows predictably, we're going to have to seal it up with a window. Now you remember how I said the shape of the object plays a big role in how the air behaves around it. So we're going to study each one of these objects in our wind tunnel just to see what the air does as it passes around the object. We're going to take these shapes and we're going to place them in our wind tunnel for observation. The first shape we're going to test of the object is the flat front. The next shape we're going to test is the round ball. And now we're going to test the airfoil shape. So as you can see from the wind tunnel demonstration, that the shape of the object really matters with how the fluid or the air behaves around it. You notice that the square, or the flat front, the air coming at it had no choice but to go up and down. Not around very much, but just it hit it and it spreads out. Whereas the circle, as the air approaches it, went that way and that way around the object on both sides. The airfoil, however, with its curved shape, flat bottom, curved shape, the air striking it went over, some went under, producing a low pressure on the top. According to Bernoulli's theorem, that increased velocity meant a decrease in pressure, so it was higher pressure on the bottom relative to the lower pressure on the top, holding the wing up in the air, producing lift. Thanks for watching.